Hello students, how you guys are doing? All good? So today let's get started with a new chapter, that is sets and their representation. Now when we talk about sets, what do we mean by sets? Very simple. In very simple terms we can say that sets are nothing but collection of elements sharing some common property. Fine? Let us take some examples. If I say a set of students in a class whose height is above 5 feet. So, what is that common property which the students are sharing? The common property which the students are sharing is that their height is above 5 feet. Fine? Let us take few more examples. But before that, let's look at bookish examples and bookish definition. Objects, elements and members of a set. These are synonymous because all are same. When I say objects of a set, elements of a set or members of a set, they resemble same thing. Fine? And here sets are usually denoted by capital letters. Always remember this. And the elements inside the set, they will be represented by the small letters, as we have mentioned in the third point. Fine? No problem, students. Very simple. Now here, if I talk about few sets which are very standard sets and are used throughout mathematics, you must remember these sets and by which alphabet they are represented. Alright, so here we have capital N. Capital N means the set of all natural numbers. Here we have capital Z. It means the set of all integers. It can be positive also, negative also, or it can be zero also. Now here we have Q. Q means the set of all rational numbers. R, that means capital R, which means the set of all real numbers. But remember one thing. Here capital Q represents set of all rational numbers, right? But if I write, let me select pen from here. If I write this way, Q complement, this represents what? This represents all set of irrational numbers. Getting it? That means set of all irrational numbers. Now if I talk about Z plus, see, here we have Z. Here we are putting Z plus. It means set of all positive integers. If I am writing Q plus, what was Q? Q was set of all rational numbers. If I am writing Q plus, it simply means set of all what? Rational numbers. Fine. And now R plus, R was what? R was set of all real numbers. R plus means set of all positive real numbers. Fine. Now over here, students, let us talk about two different methods of representing a set. One is tabular form and the second one is what? Set builder form. Tabular form is also known as what? Tabular form is also known as roster form. Fine. So let us first look at roster or tabular form. Let us take few examples. Let's say in roster form, all the elements of a set will be listed, right? And they will be enclosed within braces. So if I say like the set of all even positive integers, this is one example, the set of all even positive integers which are less than 7. So all positive integers which are less than 7, what are they? 2, 4, 6. So we are going to write them inside curly braces as I have told you over here. So this way of representing this set will be called as what? Roster or tabular form. Now always remember, it doesn't matter that you are writing elements in which order. Here I am writing 2, 4, 6. I could have written 4, 2, 6 also or 6, 4, 2 also. That means I can write them down in any order I want. So which order I am writing them in, that is not making any difference. Fine. Same thing has been mentioned over here. Set of all natural numbers which is divided by 42. That means which is, in fact here we should have which is divisible by 42 instead of divide, which is divisible by 42 or which divides 42. That is a correct statement. So these are the numbers which divides 42. Fine. Not divisible by 42, which divides 42. Which divides 42. So of course there will be factors of 42 which are 1, 2, 3, 6, 7, 4, 14, 21 and 42 itself. Now again you can write them down in any order. That is what they are mentioning over here. Same thing they have written over here. No problem, understood. Now let's look at the second one, which is the set builder form. All right. Now students, let us take some example. Let us talk about what vowels, okay? What are the vowels? A, E, I, O, U. These are 5 alphabets which form vowels in English, right? Now if I talk about vowels to be represented in set builder form, so what I'll do, I will represent them by one of the capital letters. So in a standard notation, vowels are represented by capital V, okay? So once I know that this set will be represented by capital V, now how can we express them in set builder form? First we will write capital V outside this way, okay? Now what is V? V contains elements X such that X is a vowel of English alphabet. Getting my point? V contains elements X. Let's say X1, X2, X3, X4, X5, whatever X, which is satisfying the given condition that X is a vowel in English alphabet. So what is the vowel in English alphabet? A. So X can be A. Now, what is another vowel in English alphabet? It can be E. So X can be E also. E. Similarly, I, O, U. But again, I am saying this is not the representation of set builder form. This is just a representation in tabular form. I am just trying to correlate them so that you can understand. So this is how you need to express. The set V of vowels is X. And what is X? X is nothing but X is a vowel in English alphabet. I am writing ENG dot means English and here alphabet. I hope this is clear, right? Crystal clear? Fine. Any problems, students? Understood? All right. Now, students, over here, let us take few examples. Write the solution set of this equation in which form? Roster form. What was roster form? Remember, roster form and tabular form, they are synonymous. Both are exactly same. And the other one is set builder form. So what is the solution? Of course, here we have quadratic. So at the most we can have two solutions or what? Or no solutions if we are dealing in real numbers, right? Let's talk about its root. X square plus x minus 2. So let's use the formula. This formula minus b plus minus b square minus 4ac by 2a. Using this formula minus b. So minus 1 plus minus b square minus 4ac. That means 8 plus 1, 9, root under 9, which is 3. So what I'll do, instead of rewriting this thing in another line, I will erase this over here itself and I will write root 9 as what? 3. Because I have taken the care of the sign by putting plus minus in front, okay? And since I don't have a lot of space also, that is also one of the reasons why I am erasing and rewriting at the same place. Fine? All right. 3 divided by 2 times a. Of course, the coefficient of x square is a, so it will be 2. From here, I get two values. One is 1 and the other one is minus 2. So should we leave it like this only? No, this is incomplete. We have simply got the answers 1 and minus 2. Now we need to write them down in set form, and that too in which form? Which form? Roster form, or let's say tabular form. So you're going to write the solution set. Let us represent, you can write in the exam, let us represent the solution set by alphabet S. In exam, you can write this way, let us, see, you need to write down this thing so that you can get full marks. Let us represent solution set by S. And you can write it in this way. 1 minus 2. Is this clear? Any problem, students? No problem. Understood? Sure? All right. Students, now let's take few more examples. All right. So here we have NCERT example 2. Here in this, we need to write down this set in the roster form. Now look at the question. Here they have given us in the which form? Set builder form. They have given that we have a set which is equal to x, and what is x? X is a positive integer and x square is less than 40. X is a positive integer such that its square is less than 40. Now you tell me, what is the maximum value this x can take? Can this x take a value of 7? No sir, because 7 square will become 49. That would exceed 40 and it should be less than 40. So the maximum value which this x can take is 6, because 6 square is 36, which is less than 40. So I can say that x is a positive integer and x is less than 6, right? So I should say, let us call this set as A. Okay, let us call this set as A. And what are the elements? X less than 6 and x is positive. So it will be 1, 2, 3, 4, 5 and 6. If you square each of these elements, you will figure out that their square will always be less than 40. All right. Any problem, students? Very simple. All right. Now let's move on to the next question. Here we have NCERT example 3. Now a set has been given to you in which form? Roster form, or let's say tabular form. And you need to write down this in which form? Set builder form. And here the name of the set is A. So A will be equal to what? A will be equal to x, such that x is what? What is x? Tell me, students, what is x? Can you figure out something? Here we have 1, 4, 9, 16, 25 and so on. These are what? These are square of positive or negative integers. We cannot say that 4 is square of 2. 4 can be square of minus 2 also, right? So I can say that x is a non-zero. X is a non-zero integer. Because here we don't have 0. Here we don't have 0. If we had 0 also, I would have simply written that x, A is equals to x, where x is a real, x is an integer. I would have written down that thing directly. But here x is a non-zero integer. Remember, x cannot be equal to 0 because 0 square is 0 and 0 is not featuring anywhere inside this set. So A is equals to x such that x is a non-zero integer. All right. Fine. So this is your set builder form. Fine, students. Now here a set has been given to us again in which form? Roster form, or let's say tabular form. Again we need to write down this in set builder form. Now look carefully. Here you have 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. See, whatever we have in the numerator, if we look carefully, in the denominator we have 1 more than the numerator, right? 4, 1 more than 4, 5, 5, 1 more than 5, 6 and so on in every place. Fine. But remember, this is not getting continued indefinitely. Okay. As we had over here, it was getting continued indefinitely, right? But here, the sets are closed. It is not getting continued indefinitely. Later on, we will discuss finite and infinite sets. There you will come to know that this is a finite set. A set having finite number of elements is a finite set. Very simple. A set containing infinite number of elements will be called as infinite set. That's it. Though we will study it later, but still I am talking about that in the beginning itself so that it makes some sense to you when we are discussing these kind of sets, because here we have finite number of elements. So when we are writing them down in the set builder form, we'll have to take care of that, right? Because what are the that means what are the problems and what are the mistakes which a student can do, that also I will show you. So let us call this set as set A. So A is equals to x such that x is equals to, let's say, m by m plus 1, where m belongs to what? Positive integer, z plus Remember, this sign belongs to, we have discussed this sign in the beginning in basic mathematics, right? All the notations, signs, everything. So this sign means, this one means m belongs to z plus, that means positive integer, such that m is greater than 1. All right, m is greater than 1, greater than or equal to 1, and it is less than or equal to 6. See, there are a lot of ways by which you can represent. There are a lot of ways. This is one of the ways. A is equals to x. X belongs to m by m plus 1. M belongs to what? Positive integer. And also m is lying between 1 and 6. This is one of the ways. Because generally what mistake a student can do, if they are not writing down this one, what will happen? Just look over here. What will happen? It becomes wrong. Yes, sir. Because if m is a positive integer, this m can take any positive integer value, right? This m can take a value of 10 also. This m can take a value of 5,555 also. If m is taking a value of 10, this x becomes 10 by 11. So A is taking a value 10 by 11. Do we have 10 by 11 inside this set? No, sir. That is why we need to put restriction on m. That is why here I have written that m belongs to positive integer lying between 1 and 6. Or you can write down this in words also, that m after this semicolon, that m belongs to positive integer lying between 1 and 6, including both 1 and 6. That way also you can do, or mathematically also you can write it in this manner. I hope this is clear. Fine. Now here in this question, we need to find, that means we need to match each of the set on the left described in the roster form with the same set on the right described in the set builder form. Fine, very simple. Let's do it. Here we have PRI and CL. All right. X is a positive integer and x square minus 9 is equals to 0. So x square is equals to 9, right? X square is equals to 9. That means x can be plus minus 3, but we need to exclude minus 3 since x is a positive integer. So x is equals to 3. Match each of the set on the left described by the set in the roster form. Okay. So we cannot match set, that means this 4 and set A. They just cannot be matched because they are not the same set. Always remember. Here we are having 3 minus 3, both. Here x is a positive integer. That means here we will have only one value of x, that is 3. We cannot have minus 3 over here. That means this set and this set, they are not same. Fine, remember it. Now let's talk about the second one. X is a positive integer and is a divisor of 18. That means all the factors of 18, right? And it should be positive. So positive integer and it is a divisor of 18. So what are the factors of 18? 1, 2, 3, 6, 9. What else? 18 itself. All right. 1, 2, 3, 6, 9, 18. That means this is present in this number 3. That means 3 and B, they are same. So I will write this way. 3 matches with B, or you can write in this manner. 3 and over here B. That means in this way you can say that they are getting matched. All right. Now let's talk about the set in option C. X is an integer and x plus 1 is equals to 1. All right. That means if 1 goes that side, x becomes 0. And x is an integer. That means x is 0. Where is 0? 0 is present in option 2. All right. So set in option C and set in option 2, both are same. So I will write 2 with C. Now let's see what set do we have in option D. X is a letter of the word principal. All right. Now always remember, if I have set containing 2 elements, for example, let me give you one example. I have one set containing 2 elements, 2, 3. And let's say I have another set containing these many elements. Students, what can you say about these two sets? Are they same? or are they different? They are exactly same. Even if I am repeating the same number of elements, that means if I am repeating the already existing elements, it is not going to make any difference. The set remains same. That is why, what are the elements we have in this set? 2 and 3. No matter how many times you're repeating 3, that doesn't make any difference. That's why both these sets are exactly same. Remember it. So here, what are the letters we have in this word? Tell me, students, what are the letters we have? We have letter P. Let me put one arrow so that you can remember very well. P, we have R, we have I, we have N, we have C, we have I. Here we have I, but we have already taken care of I over here, right? That means we are not going to repeat it to avoid confusion. Again, we have P, right? But P has been taken care of over here. Now here we have A. Have we taken care of A already? No, sir. So now we need to take care of A. Now here we have L. Have we taken care of L already? No, sir. So let's put an arrow on top of L. So we are having how many elements? How many unique elements? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Have we repeated something? P over here. R, alright, R. Here also we have PR. Here I. Here also I. Here N. Here also N. Here C. Here also C. AL. Alright, AL. Fine. A will be over here. They have missed out A. So let me erase and let me rewrite A. I can write A in the last also, because in which order I am writing them down, I have showed you that it is not going to make any difference. So if you want, you can write A then L, or if you want, you can first write L and then A. Both are same. So students, can we say that this option 1 and this option D, both are same sets? No, sir. All the elements are not same. Here A is present in this set. Alright. Do we have A in this set? No, sir. That means these two sets are not same. If we had A present in this set, then we could have said that yes, these two sets are same. Understood? So only these two sets are getting matched. Fine. So let's say I don't remember whether in the book they have given A over here or not. If A is there, that means these two sets can be matched. Otherwise, you cannot match them. Fine, students. Now here we have another exercise problem. Which of the following sets are, that means which of the following are sets we need to justify our answers. The collection of all months of a year beginning with the letter J. What are the months? First one month is January, alright. Then another one is Feb, March, April, okay, May, June, July, August, September, October, November, December. So what are the months which are starting with J? First one is Jan, that is January. Then which are the other months? June, July. So we have 3 months, January, June, July. So of course they are sharing a common property that they are starting with J. So it is a set, right? Because what is a set, students? You tell me, I've told you. Any elements, that means some number of elements, they could be finite number of elements or it could be infinite number of elements also. It's just that they will share some common property. Fine. Now here we have the collection of 10 most talented writers of India. 10 most talented writers of India. Now we cannot call this as a set because for different people will consider different writers as talented. So you cannot group them as 10 talented people, because for some person there can be some 10 number of talented people, right? For some other people, he can have some other 10 talented writers, right? So we cannot say that they will have some common property. You cannot figure it out. 10 most talented writers, because it will vary from person to person. It is not fixed. Fine. That is why option 2 is not a set. So the options which are set, I am putting one tick over there so that you can understand that it is a set. When I am not doing anything, you should understand that it is not a set. a team of 11 best cricket batsmen of the world. Again it is a controversial thing. Somebody will say, I like AB de Villiers. Somebody will say, no, I like MS Dhoni. Somebody will say, no, I will go with Sachin Tendulkar. So it is a controversial thing. For different people, different batsmen can be great. Okay, you cannot say that which is the best 11 batsmen. I can form a team of 11 best batsmen in so many ways according to so many people. So again, it is not a fixed thing. So it is again not a set. So I'm leaving it as it is. The collection of all boys in your class. Yes, it is a set because there cannot be any disagreement that yes, no, he is not a boy. If somebody is a boy in a class, will you ever disagree that no, he is not a boy, he can be a girl also? Will you ever do that? Of course, you won't do that, right? You will, means all the students will unanimously agree that yes, the given child in a class is a boy or he's a girl, right? So of course, you all will agree that who all are the boys in the class. So they will form one set that yes, they are males and they are boys of the class. So yes, it is a set. There cannot be any disagreement and it is a fixed thing. The collection of all natural numbers less than 100. Yes, sir. There again cannot be any disagreement in this. It is a mathematical statement, right? So it has to be a set. Collection of all natural numbers less than 100. That means all the numbers beginning with 1, right? And going up till 99, right? Because it is less than 100. So it is again a set. A collection of novels written by the writer Munshi Premchand, right? You know this writer, Munshi Premchand. He's a very famous writer of Hindi. Very famous. You must read, if you are interested in Hindi books also, you must read his books. They are very engrossing and very good. I have read them personally. That's why I'm saying. Of course, you can do that in your free time, right? So Munshi Premchand, of course, you can have collection of all his written novels in one place. So they will form one set. So it is a set. The collection of all even integers. Of course, mathematical statement has to be said. There cannot be any disagreement, right? The collection of questions in this chapter. See, the collection of questions in this chapter. Fine. If questions have been already framed, mark my words, if questions have been already framed at the end of the chapter, you can say that yes, it is a collection because you are collecting all those questions and they share a common property that they are the questions, and in the end of the statement they will be followed by a question mark. So they are questions. The common property is that they are questions. If you have questions at the end of the chapter which are already framed, then you can say that yes, it is a set, right? But if the questions are not already framed, you need to frame the questions, and then you need to form the collection of questions from the chapter. Then again, there can be a lot of disagreement. People can say that here also I can form one question. Somebody will say that no, these two questions are almost same. How can you say that these two questions are different? In that case, it will no longer remain a set. But here we are assuming that questions are already framed and they are questions. So the common property is that they are questions. Hence, it can be collected in a set. That is why I have selected it as a set. Fine. Now, if I talk about a collection of most dangerous animals of the world, again here there can be disagreement. Again, for example, let me give you one example. Do you all watch Discovery Channel? I hope you all must be watching, okay? Even if you're not watching, I'll give you the example. Let's talk about two most dangerous snakes in the world, which I don't consider. I'm not saying I consider them as the most dangerous snakes in the world. Whole world consider them as the two most dangerous snakes in the world. They are Black Mamba and Taipan. If you want, you can Google these names, Black Mamba and Taipan. Fine. Some of you might argue that no, sir, it can be King Cobra also. But these two snakes are most venomous, not just most venomous in terms of everything. Their quick reaction, their speed, agility, their poisonous factor, everything. These two snakes are the most dangerous ones, Black Mamba and Taipan, which is considered by the whole world, right? But as we move down, some people will say that no, sir, that this Kret snake is more dangerous because even though cobra has more venomous snake and it can kill a lot of people, but kret actually kills more people than cobra. So somebody can consider kret to be more dangerous, because what happens when kret bites you? When kret bites you, you will not even come to know that kret has actually bitten you. And in no matter of time, no time, what will happen? That poison will get spread in your body and you will not even know that you have been bitten by kret. But in case of other snakes, you will definitely come to know because you can feel a pain. That is why varying from person to person, this is a very controversial thing. Somebody can say that, yes, I consider this to be more dangerous, or somebody can say that, no, I consider this to be more dangerous. So there can be a lot of disagreements, right? So here we cannot say that which are the most dangerous animals of the world. Fine, we just cannot say. So this is not a set. By mistake, I have given a tick mark. So I need to remove from here. I hope this is crystal clear, students. Understanding what are sets. There cannot be any disagreement also. It should be a fixed thing, right? It should be a fixed thing. It should what? It should share some common property. Fine. Now, fixed thing means what? That means there cannot be any disagreement from person to person, from opinion to opinion, right? Getting it? Now, here we have few things. Let's look at these symbols. This is not I and I dot. These are nothing. Let me show you what they actually are. They are this thing, belongs to, and this one doesn't belongs to. Belongs to, doesn't belong to. We have discussed this in basic mathematics also, right? All right. Now here we have set A. And actually here you have nothing but just a line, straight, just a line. That means just a blank space which you need to fill either by this sign or by this sign. So here we have this set A, all right? Does 5 belong to set A or 5 doesn't belong to set A? Let's see. 5 belongs to set A. So I will give this sign. 8 doesn't belong to this set, right? So I will write A doesn't belong to this set. 0 belongs to set A. No, sir. 0 doesn't belong to set A. So again this sign. 4 belongs to set A. Yes, sir. 4 belongs to set A. So this sign. 2 belongs to set A or not? 2 belongs to set A. Yes, sir. So this sign. 10 belongs to set A or not? 10. No. 10 doesn't belong to set A. So which sign? This one. Clear, students? Getting it? All the notations, examples, what are sets, what is set builder form, what is roster form, how to represent, how to write in words, how to write in mathematical form, everything? Sure? Good. Now, here in this question, again we need to write down the set in which form? Roster form. Alright? So over here, a set C is given, which is a 2-digit natural number such that the sum of its digits is 8. Alright? Let's first begin with the first digit as, that means a digit in the tens place as 1. So what will be the another digit? 7. Then only 1 plus 7 will be 8, right? Let's take first digit as, that means a digit in the tens place as 2. So another will be 6. Then only 2 plus 6, 8. Similarly 3, 5, 35, 4, 4, 44. Alright. Then reverse of this, 3, 5, then 5, 3. 5, 3. Okay, it is a 2-digit natural number such that the sum of its digit is 8. Then again, permutation of 2 and 6, right? Getting interchange. 2, 6, so 26, over here 62. Here 17, so over here 71. So these are the 2-digit natural numbers such that their sum is 8. And it is set C. Fine, this is we have written in the roster form. Now let's come to the second question. This was question 1. This is question 2. E is a set of all letters in the word trigonometry. So how you need to select the words from this, that means select the words from this word trigonometry so that you don't repeat them. How can you do that? I'll tell you a method. As we have done earlier, put one arrow over T. That means you have selected T. Then one arrow over R. Then one arrow over I. And at the same time, what you need to do, you need to see that whether whatever you're selecting on the right hand side, you need to match it with the letters on the that means with the alphabets on the left hand side, whether you are repeating it or not. I, have you repeated I? Have you selected I before? No, sir. That means it is correct. Now you are selecting G. Have you selected G already? No, sir. Now here it is O. Have we selected O already on the left hand side? No, sir. That means you can select O. Now here comes N. Have we selected N already on the left hand side? No, sir. That means N can be selected. Here comes O. Have we selected O already in the left hand side? Yes, sir. We have already selected O. So I will not put one arrow on top of it. No. Here we have M. Have we selected M already? No, sir. So we need to select M. Here we have E. We have not selected E before. So we are selecting E. Again, we are getting T. Have we selected T already? Yes, sir. We have selected T already. So I will not put one arrow over here. Similarly, we have R also. We have already selected R also on the left hand side. So I will not select it again. Here we have Y. Have we selected Y already? Beforehand, no, sir. So we will select Y. Now, the alphabets on which I am having an arrow on top of its head, I am going to select those and I will say that these are the letters in the word trigonometry. Fine. So let me do that. This is set E. So what will happen? This way you will avoid repeating the same alphabet. Fine. First one T, then R, then I, then G, then O, then N, then M, followed by E, then followed by what? Followed by TR has been already taken care of, then followed by Y. All right. So this is the set E in the which form? Roster form. I hope this is clear. Now in this question, we need to write down the following sets in the set builder form. Okay. So let me, for the question number 1, let me call this as set A. So set A is X such that X is what? Tell me. Tell me X is what? Here we have 3, 6, 9, 12. What do we have over here? These are multiples of 3. Okay. But it is not getting continued indefinitely. It is again a finite set. That means multiples of 3 starting with 1. That means 3 into 1 is 3, going up till 3 into 4, that is 12. Alright. So I will write A is X such that X is equals to 3M. Alright. Where M belongs to positive integer and M belongs to positive integer and M is lying from where to where? From 1 up till 3 into 4, 12, up till 4. Or again, I will tell you one more thing. You can write down this thing in words also. That A is equals to X, X is equals to 3M. And here you can write, and M belongs to positive integer starting from 1 and going up till 4. This way you can also write and still you will get full marks. Getting it? So this is set A. Now let's come to set 2. That means question number 2. Let us call this set as set B. Alright? Alright. Now what do we have over here? 2, 4, 8, 16, 32. Double of 2, 4, double of 4, 8, double of 8, 16, double of 16, 32. So it is basically powers of 2. 2 to the power 1, 2 to the power 2, 2 cube, 2 to the power 4, 2 to the power 5. So I can straight away write that B is equals to X, where X is 2 to the power M, K, whatever it can be. I am writing it K over here because I have already written M. Whichever alphabet you want, you can take that. 2 to the power K, such that K belongs to Z plus, and K is lying from where to where? It is starting from when? 2 to the power 1. So K is starting from 1. K is greater than or equal to 1. And it is going up till where? It is going up till 2 to the power 5. That is 32. Less than or equal to 5. Here if you want, you can put one and also. Your marks is not going to get deducted for this one. And over here. You can do that also or this way also. Both are correct. Both are correct. Fine. Got it? Agree? Understood, students? No problem? Sure? All right. Now here, let's talk about empty set. Now, let's say if I'm talking about something, okay, if I'm saying that here I am talking about this set and I will contain, that means I will put only those elements inside this set which will satisfy this common property. But let's say there is no such element which is satisfying the given property. That means that set is an empty set, or it is also called as null set, because there won't be any such element which will be satisfying the given property. Let us try to understand this by taking few examples. A set which doesn't contain any element is called empty set. But why will a set not contain any element? That is the question. Because whatever will be the given condition, that means whatever will be the given property for the element to be satisfied, none of the elements is going to satisfy that given property. Hence, they cannot fit in the given set. So that set then becomes a null set, or let's say empty set. Fine. Let's take few examples. Here we have x. X is greater than 1 and x is less than 2. And x is a natural number. Here they have missed out number. X is a natural number. Now, do we know any natural number which is lying between 1 and 2? No. Because between 1 and 2 we don't have any natural number. That means we cannot have any value of x which is a natural number greater than 1 and less than 2. So this set A is what? This set A is an empty set. You can write it in this manner. That over here we have this set A. So set A is an empty set. You can write this way, that it is a null set or empty set, or also called as void set. Fine. This is how you can represent this null set. Now let's take one more example. X square minus 2 is 0. If x square minus 2 is 0, that means x square is 2. So there can be two values of x, plus minus root 2, right? But here they are saying that x is a rational number. You can clearly see that the value of x which is satisfying this equation is an irrational number. Plus root 2, minus root 2. Both are irrational numbers, right? So we cannot have a value of x which is rational also, and at the same time it is satisfying this equation also. That means we don't have any such value of x. That means again set B is an empty set. So you're going to write in this manner that B is an empty set. Fine, students, no problem. All right. Now let's talk about finite and infinite sets. I've already given you an idea about these sets earlier, right? Finite sets, very simple. Any set containing finite number of elements, that will be called as finite sets. That's it. Any set containing infinite number of elements, they will be called as infinite set. That's it. Here, same thing they have written down. They have written down in words. Okay. For example, let's take few examples. Let W be the set of all days of the week. So how many days we have in a week? 7 days. So it is a finite set. They are limited by 7 elements in that set. What are the 7 elements? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. That's it. It is finite. Then let's coming back to the second question, that is set S. Set S be the set of solutions of the equation. X square minus 16 equals to 0. That means x square equals to 16. So x is plus minus 4. So again we have only 2 elements inside set S. So it has to be finite, right? Now let's come to the set given in question 3, or let's say in point 3. Let G be the set of all points on a line. So G is an infinite set. Students, how many points do we have on a line? Of course, infinite number of points. So G has to be an infinite set. That's it. Fine? All right. Now here, we need to state that which of the following sets are finite and which are infinite. X belongs to natural numbers and it is also satisfying this. X minus 1 into x minus 2 is equals to 0. So here we are getting two values of x. X equals to 1 and x equals to 2. Okay, so if I call this as set A, so A will contain 2 elements, 1 and 2. First of all, it has to satisfy this equation, At the same time, it has to be a natural number, right? So of course 1 and 2 both are natural numbers, so both of these satisfy the condition to be inside this set. They are finite or infinite? Very simple. Obviously it is finite, right? Because here we have only 2 elements. If you can count the number of elements inside the set, that is finite. If you cannot count them, it is not a finite set, it is an infinite set. X square equals to 4. Again, we have two values of x, plus 2 and minus 2. But here they are saying x has to be a natural number. Minus 2 is not a natural number. That means x equals to 2 is the only natural number which is satisfying this equation x square equals to 4. So let's call this set as set B. So set B will contain only one element, that is 2. Again, it is finite set. Now here x is a natural number and 2x minus 1 is equals to 0. If you solve this, you will get x equals to half. X equals to half. And x is a natural number. X is half and x is natural number. Is half a natural number? No, sir. That means you don't have any natural number which is satisfying this equation. That means this set is a null set. So this is, let us call this as set C. So set C is a null set. So again, it is a finite set, right? Because we don't have any element inside this set. How many elements do we have inside this set? 0 elements we have inside this set. So it is again a finite set. Always remember that empty set is a finite set. All right. Now here we have x belongs to natural number and x is prime. Now all prime numbers are also natural numbers, right? And how many prime numbers do we have? We have infinite prime numbers, right? And all the prime numbers are natural numbers. That means it is not a finite set. Let us call this set as set D. And they will be something like this: 2, 3, 5, 7, 11, 13, so on. So here we have infinite number of elements. So it is an infinite set. All right. Now here, coming back to the point 5, x belongs to natural number and x is odd. Again, all odd numbers, all even numbers. That means all positive odd numbers, all positive even numbers, they are also natural numbers, right? So all odd numbers is natural number or not. Always remember, when we talk about odd numbers, 1 is also odd, 3 is also odd, 1, 3, 5, so on, which are not divisible by 2, they are odd. And the negatives are also odd. Minus 1 is also odd, minus 3, minus 5. So don't think that negative numbers are not odd numbers. No. Negative numbers are also odd numbers. And same thing for the even numbers. All numbers which are divisible by 2 is an even number. 2, 0, 4, 6, 8, they are even numbers. Minus 2, minus 4, minus 6, minus 8 and so on, they are also even numbers. So odd numbers and it has to be natural, right? Let me call this as set E. So here we can have 1. Can we have minus 1? Can we have minus 3 because they are odd numbers? No, sir. First of all, it has to be odd. At the same time, it needs to be natural number also. Minus 1, minus 3, they are not natural numbers. Natural number starts from 1 and goes up till where? Infinity. So this set is 1, 3, 5, 7, all positive odd numbers. Okay. So here we have infinite number of elements. So this is again an infinite set. I hope this is crystal clear. Sure? Good.